This is the tutorial on referring to the question on proposed mechanism for decomposition of ozone. So this is a correction with regards to our discussion, which is last week on kinetic tutorial. So the last part of the question is about the rate equation based on proposed mechanism. Okay, so if you look back at the tutorial question, you will find this equation. And if you look at this equation, O3 reversible decompose into O2 plus oxygen atom. And the second equation is oxygen atom plus O3 forming 2 oxygen molecule. And the overall reaction is 2O3 forming 3 oxygen molecule. The question is asking to derive the rate equation based on this proposed mechanism. So the steps that we have discussed during the tutorial on kinetics, we have to give focus on the rate limiting steps. So if we look at this, the slowest step is the rate limiting steps. Right. Now, if we look at this rate equation for the rate limiting steps, let us consider the K as K2, then R equal to K2 times oxygen atom times concentration of O3. There are rules that we have if it is involve an intermediate, we have to replace the expression of intermediate into something else. And the way that we do it, if we look at here, okay, if we look at the fast reaction, and it is a reversible reaction, so we can write the rate for the reversible reaction, okay? So if you look at the question, K1 is the rate constant for the K1 O3, okay, is equivalent to, because it is a reversible reaction, we can name it as K minus 1, okay, of the product, because it is a reversible reaction, okay. Now, you can see that there is an oxygen atom expression there, and then we can rearrange the rate equation expression into this form. So you can see now the oxygen atom concentration can be represented using this expression. Okay, so the next step is to replace the oxygen atom expression with this expression inside the rate limiting step rate equation. So you can see here, after replacing the this oxygen atom, okay, here into the rate equation of the limiting steps, then we can see that the final expression for the overall rate equation is K times O3 with the order of 2, which is by molecular. Okay, so this whole thing, okay, right? This whole expression now can be lumped up into the rate constant, the final rate constant, which is K, right? So this is the final rate equation. So this is the rate law equation for overall reaction. Okay. Now let's look at the next question. If you refer to the tutorial again that we discussed during the kinetic, but we didn't solve it. Okay, we have this nitrogen plus chlorine, and we have a reversible reaction forming N2Cl. And we have a slow reaction, N2Cl plus Cl. The slow reaction, N2Cl plus Cl, forming Cl2 plus nitrogen, N2. And overall reaction, we can see that it is 2Cl forming a chlorine molecule, Cl2. Okay. And the question is asking to identify intermediate. And B, is this consistent? Is the mechanism here? Is the mechanism proposed here is consistent with experimental law? So we have to prove by using this mechanism that it is suitable, consistent with the experimental observed from the experiment. So the first thing is to identify intermediates. So how to identify intermediate? The definition is intermediate is produced at the beginning. So for example, if you look here, N2Cl is produced, but in the final overall reaction, the intermediate will not be there anymore. So you can see in the overall reaction, N2Cl is no longer in the overall reaction. So N2Cl is the intermediate. So how do we solve D? So again, the same steps. We have to focus on the slowest reaction and write the rate equation. So the rate for the slowest reaction, let us put K2 as the rate constant. And then we look at the slowest step, the concentration of N2Cl times concentration of Cl here. So now, we can see that there is an intermediate involved in the rate equation. Okay, so the rules is intermediate cannot be used to determine the actual the proposed rate equation for the overall reaction. So what we can do is to again to replace the expression the N2Cl. Okay, how we gotta do that? We use the same steps. Okay, and remember that the fast the fast reaction is reversible. So what we can do is to write this way. The forward reaction K1 N2Cl is equivalent to the backward or the reverse reaction K minus 1 N2Cl. So this is based on the fast reaction. Okay, so now we rearrange the equation so that now N2Cl can be expressed in this form. And what we can do is to replace, okay, the expression of N2Cl here, okay, with the new one, okay. This is where we replace the N2Cl. So from here, we can this will represent the value of K, okay. And then from here, the nitrogen is maintained and the Cl now is Cl2. So based on the question, is this mechanism above, okay, consistent with the experimental law, which is R equal to K times concentration of nitrogen times concentration of chlorine with the order of 2. So we finally managed to prove that. Means that it is comply to the suggested, to the observed experimental rate law.